Hello students, welcome to this video session. In this demonstration, I'm going to discuss the worksheet number system which I posted on 6th April in Google Classroom. Okay, fine. Without any further delay, we can just jump into our lesson. Okay, let us see the first question. The first question says convert the following deanery numbers into hexadecimal numbers, right? So deanery number means like a number with base 10. Basically a number with base 10, we call that number as a deanery number, right? So usually starting from 0 to 9, so altogether actually 10 digits will be there, right, in the deanery number. And the hexadecimal number, in hexadecimal number 16 digits or notations will be there, like starting from 0 to 9, then A, B, C, D, E and F. Okay, so instead of 10 actually it will be, so this will be 10, this one will be 11, then this one will be 12, then this one will be 13, then this one will be 14, and this one will be 15. All together you can see here like 16 hexadecimal 16 characters will be there, like 0 to 9, 10 digits, and A, B, C, D, E, F. Okay, so altogether like 16 notations will be there. Okay, fine. Here our question says like you have to convert this deanery number, means 98, this deanery number you have to convert to hexadecimal number, right? So when you're going to convert a deanery number to a hexadecimal number, so always you have to divide that particular number by 16, isn't it? So say for example like 98 divided by 16. Okay, 98 divided by 16. So here we can see like 6 times 6 times 16, 6 times 16, you will be getting like 96, isn't it? So you will be getting 96. So 98 minus 96, it will be 2. So you have to keep the remainder here. Okay, when you're writing the answer, how to write the answer means it is 6 to base 16. This is the first answer. Okay, for the first question the answer is 62 base 16. Okay, this is the first answer. So this is the way how to convert. So 98 you have to divide by 16. So 6 times 16 actually it is 96. So this 98 minus 96, you will be getting the remainder too. So you have to keep that remainder here. Okay, when you are writing the answer you have to start from here and you have to go like this. Okay, so so it will be like 62. So the final answer is 62 base 16. This is the final answer for the first question. Okay, now question number, that is B. So that is 227, right? 227 you are going to convert from deanery number to hexadecimal number. So you have to divide this one using the number that is 16, right? So first actually we can't take the single digit because this number is smaller than 16. So you have to take this first 2 digits you have to take. So when I take that one 1 times 16, actually it will be 16, right? So 1 times 16 it is 16. So 22 minus 16, it will be 6. So now this will become like 67, right? It will become 67. Now actually 4 times 16. Okay, 4 times 16 it is 64. 4 times 16 it is 64. So 67 minus 64, that will be the 3. Okay, So how to keep the remainder 3 here. Now how to write the answer, how to write our final answer means from here actually how to go, and you have to go like this, isn't it? So first let us see actually 14. 14 means the hexadecimal notation, that is E, isn't it? So our answer is E3 base 16. Okay, this is the second answer. Okay, now let us move on to the next question. The next question is 490, right? So take the number 490. It's a deanery number, so you have to divide this one by 16, right? So here it is 30 times 16. So 30 times 16, actually it is 480, right? So the remainder will be 10. Okay, so already I told that until you get here actually a number 16, you have to keep on divide, isn't it? So again you have to divide this one by 16. So here actually 1 times 16, it is 16, so the remainder will be 14, right? The remainder will be 14. So now how to write the answer? You want to start from here and you have to go like this, right? So it is 1, 14, then 10. So you have to convert actually these numbers to the hexadecimal notations. 1 usually 1, then 14 means that is E, right? Then 10 means it is A. So our final answer is 1E A, it's base 16, right? So here we can write the answer for the third one. It is 1E then A base 16. This one is the final answer. Okay, now let us see the next question. Next question is 511. Okay, so you have to divide this one by 16. So 3 times 16. So 3 times 16, it is 48, isn't it? So 3 times 16, it is 48. Here actually 51 is there. So the remainder actually it will be 3, right? So 3 means this will become 31. So this will become 31. So 1 times 16, it is 16. So the remainder will be 15, right? So 31 minus 16, you will be getting the remainder 15. So again actually still we can divide by 16. So here 1 times 16, actually it is 16. So again actually 31 minus 16, you will be getting the remainder here, that is 15. So now you want to start to write the answer from here, right? So it will be like 1. So for 15 actually the hexadecimal notation is F, right? So 2 times actually F you have to write. So the answer for 511 is 1 double F, right? Now the next question, it is 826, right? 826, the answer is 3 3 8. Okay, this is the answer for this question. The next one is 1000. For 1000, the answer is 3 E 8. This is the answer. Okay, now let us move on to the last question, that is 2634, right? So you have to divide this one by 16. So divided by 16. So first you can take these two numbers. When you take these two numbers, like 1 times 16, it will be 16, right? Now 26 minus 16, you will be getting 10, right? So now this will become like 103, right? This will become 103. Now 6 times 16, 6 times 16, actually this will be 96. So 96 means now 103 minus 96, you will be getting like 7. Now the last digit actually, that is 74. Now this will become 74, right? Now see, the last one is 4 times 6, that is 64. So 74 minus 64, that will be 10, right? So how to keep the remainder here. Now again, actually how to divide this one by 16. Now 10 times 16, it is 160, right? 10 times 16, it is 160. So 164 minus 10, 164 minus 160, actually again you will be getting the remainder 4 will be there. Okay, so now how to write the answer, you want to start from here and you have to go like this. So for 10 actually it will be A, then this will be 4 as it is, you have to keep here, then again actually 10 is there. So the final answer is A for A. So the last answer is A for A. That is the final answer. Students, in case if you feel dividing by 16 it's bit difficult, means what you can do means first you can convert the number, the deanery number, to like binary number, then that binary number you can convert to the hexadecimal number. It's a lengthy process, but still actually you can get the correct answer. How to do that one means, let us see the first one. First, what you have to do means you have to convert this deanery number to the binary number. Take the number 98. Okay, then you have to divide this one by 2. So 4 times 2, it is 4 times 2, it is 8. So here actually the remainder will be 1, so you will get this one it will become like 18. So 9 times 2, it is 18. So here actually you can keep 0. Then again you have to divide this one 2. So 2 times 2, it is 4, then 4 times 2, it is 8. The remainder will be 1, right? Again you have to divide this one by 2. So 1 times 2, actually it is 2, and 2 times 2, it is 4. Remainder will be 0. Again how to divide by 2. 6 times 2, it is 12, right? The remainder will be 0. Still how to divide by 2. 3 times 2, it is 6. The remainder will be 0. Divided by 2. 1 times 2, actually it is 2. The remainder will be 1. So our answer is like this, isn't it? So how to write the answer? 1 1 0 0 0 1 0. Okay, this is not our final answer. Now actually how to convert this binary number to hexadecimal number. So what actually how to do, how to take the number like 1 1 0 0 0 1 0, right? Now you have to group the numbers like 4 digits, as in 1 2 3 4. So you can keep a vertical line here. The top you have to keep like a 1 2 4 8, right? And here also 1 2 4. Okay, so wherever like what you tell the 0 is there, you can strike out that one. This one we can strike out this one. So the remaining one is 2, isn't it? So you can keep 2 here. Here only 1 0 is there, so you have to add these 2. You will be getting like a 6, isn't it? So our final answer is like 6 2, right? So in this way also you can solve this problem, but it's a bit lengthy. If you feel like dividing by 16, if you feel that one is difficult, means this method you can follow, right? Okay, now let us move on to the next question. That is question number 2. Convert the following hexadecimal numbers into deanery numbers. Okay, so here part A, it says like the hexadecimal value is 6B. Okay, So what is the first step you have to do? Means you have to convert this hexadecimal notations to a deanery value. For 6 it is obviously it will be 6. B means it will be 11, right? Okay, now keep the position value for this one. The position value for this one is 16 to the power 0. This one will be 16 to the power 1. Okay, now in the next step, I have to take this 11 times 16 to the power 0, it will be 1, right? So keep this one inside the bracket, then plus here, 6 times 16 to the power 1 is 16, right? Keep this one inside the bracket. When you calculate this one, 6 times 16, it will be 96, plus 11 times 1, obviously it will be 11. So when you add this one, you will be getting the final answer, that is 107, right? Base 10, because this one is the deanery value. So the first one, the answer is 107 base 10. That is the first answer. Okay. Now the B part, that is 9C. Okay. So what is the first step you have to do? You have to convert this hexadecimal notations to deanery value. 9, obviously it will be 9. Then C means it will be 12, right? Okay, now keep the position value for this one. For C is 16 to the power 0. This one will be 16 to the power 1, right? Now 12 times 16 to the power 0, it is 1, plus then 9 times 16 to the power 1, it is 16, right? So keep that one inside the bracket. Now when you calculate like 16 times 9, so you will be getting like 144, right? Plus this one, 12 times 1, 12 times 1, obviously it will be 12, right? So equal to, what is the final answer? It is 156 base 10. Okay, so the second answer is 156 base 10, right? The next question answer is for 4a, the answer is 74. Okay, then double F means it is 255. Then 1 double F means the answer is 511. Okay, it's 511. The next question answer is 2561. Okay. Okay, now the last question, it is B4, right? So first what you have to do, you have to convert this hexadecimal notation to a deanery value. When you convert this one will be 11, this one will be 11, and obviously 4, it will be 4, right? Now keep the position value for this one is 16 to the power 0, this one is 16 to the power 1, and this one is 16 to the power 2, right? So here the next step, 4 times 16 to the power 0, it will be 1, right? Plus 11 means this 11 times 16 to the power 1, it is 16, right? Keep that one inside the bracket. Then the last one, it's 11 times 16 to the power 2, it's 256, isn't it? So 256. Keep that one inside the bracket. Okay, now when you calculate this one, you will be getting the answer 2816, plus for this one you will be getting the answer like 176, right? Plus this will be 4. What is the final answer? Means when you add these three, you will be getting the final answer, that is 299 6 base 10. So this is our final answer. So for double B4, the answer is 2996 base 10. Okay. Okay, now move on to the next question. The next question is convert the following hexadecimal numbers into a deanery system and a binary system, right? So the first one is A1, right? So you have to convert this hexadecimal notation to a deanery value. So for A, obviously it will be 10 and this one will be 1, right? And next step is you have to keep the position value, right? So it is 16 to the power 0, 16 to the power 1. Now it's 1 times, it is 16 to the power 0, it will be 1, right? Keep that one inside the bracket. The next one, 10 times 16 to the power 1, it is 16, right? So now it is when you calculate this one, you will be getting like 160 plus 1 equal to 161 base 10. The answer for the first one is 161 base 10. Okay. The second answer is 55. Okay. The third one is 255. 255. Okay. Then the next one is it's 13. And the last one is 2748 base 10. 2748 for this ABC. Okay. Now let us move on to the next question. In the next question, two binary values are given, right? And they're asking you to convert one of this binary value. And they're asking actually to convert this binary number to a deanery equivalent number. So what is the binary number? Means 11010010. You have to convert this binary number to a deanery number, right? So how to convert this binary number? First take the number, say for example 11010010, right? Then you have to keep the place values on the top, like 2 to the power 0, 2 to the power 1, 2 to the power 2, then 2 to the power 3, then 4, then 5, then 6, then the last one is 7, right? The next step, you have to strike out the 0 value, like here 0 is there, you can strike out that one, this one we can strike out, this one we can strike out, and we can strike out this one, right? Now the next step is you have to find out the value for 2 to the power 7. So what is the value for 2 to the power 7? Means it's 128, right? Plus 2 to the power 6 means it is 64, plus then 2 to the power 4 means it is 16, right? Plus 2 to the power 1, it is 2. So finally you have to add all the numbers. So you will get 210, right? 210 base 10. This is our final answer. Okay. Okay, now let us see the next question. The next question says you have to convert the following binary numbers into deanery numbers and hexadecimal numbers. Okay. how to convert to means the binary numbers. You have to convert to decimal numbers, means denary numbers and hexadecimal numbers, right? So first take the first number. The first number is 0, 0. Four zeros are there, right? Then double one, double one, double zero is there. So what is the first step you have to do? You have to keep the place values like 2 to the power 0, 2 to the power 1, then 2, then 3, right? Then 2 to the power 4, then 5, then 6, and the last one is 7, right? So now where 0 is there, you can strike out that one, this one, this one, then this one, and this one, and this one also you can strike out, this one also you can strike out. Now you have to see the first one. The first one is 2 to the power 2, means it will be like 4, isn't it? 2 times 2, it is 4, plus this one 2 to the power 3, means it is 8, right? So 8 plus 4, it is 12. So base 10, right? This one is the deanery value for the first one. So this one is the deanery value. Say for example 12 is the deanery value. And you have to find out the hexadecimal value also. To find out the hexadecimal value, what you have to do? So take the same number. So 4 zeros are there, the first one, then 1 1 0 0, right? And next up we have to group the numbers. Each group must be having like 4 digits, like 4 binary values will be there, isn't it? So from the right hand side we have to take like 1 2 3 4. So you can keep a vertical line here, 1 2 3 4. Now in the next step you have to keep the place values like 2 to the power 0, 2 to the power 1, 2 to the power 2, and 2 to the power 3, right? So now wherever 0 is there, you can strike out that one. So then 2 to the power 3 means obviously it will be 8, isn't it? So 8 plus here this will be 4. So this will be 12, right? So here all the numbers are 0. Obviously it will be 0, right? So 12 means in hexadecimal notation. In hexadecimal notation, that is C, right? So our final answer is C base 16. Okay, this is the final answer for the first question. Okay, now let us move on to the next question. That is letters from the alphabet are represented in a computer by the following deanery base 10 values: A equal to 97, G equal to 103, I equal to 105, so on. So like that, some alphabetical characters are there, corresponding ASCII codes are given. So what is meant by ASCII means American Standard Code for Information Interchange. So this is the expansion for ASCII, okay? So ASCII expansion is American Standard Code for Information Interchange. Means for each and every character which is on the keyboard has the corresponding ASCII codes. So these ASCII codes, it will be in the form of like deanery values, like A equal to 97, B equal to 98, C equal to 99, and so on. So first, actually, when you press a key on the keyboard, uh, either actually it's alphabetical characters or numbers or special characters, whatever may be, that character, it will be converted to a deanery value, right? Then the deanery value will be converted to a binary code which the computer can understand. Okay, that's all about the ASCII code. So now back to our question. The word align is stored as 97, 108, 105. 103 and 110. So like that for each and every character, the corresponding ASCII code is given. Okay. Convert each of the 5 values to binary. The first one has been done for you. Okay, the first one, the answer is given in the below table. So in the below table you can see letters in the first column, it is given A, and corresponding ASCII code is given, and the next side even letters and the deanery value. Below that actually the corresponding binary numbers are there, right? So you have to convert the ASCII codes, the deanery values, to the binary code. The question says you have to convert the deanery value, means the ASCII codes to the corresponding binary codes you have to convert. So how to convert this one means you can use the trial and error method here. Okay. So usually what we will be doing means so on the top of this number, from the right hand side, you have to keep the position value. So for this, the position value is like 1, then 2, 4, 8, then this one is 16, then this one is 32, then 64, 128, right? You know how I got these numbers, isn't it? 2 to the power 0, 2 to the power 1, then 2 to the power 2, so on. Okay, so here the first one is 97, isn't it? So 97 means I have to construct this number using the numbers from this list. Means on the top of this each and every binary digit, the position value is there. No? I have to construct this 97 using this one. I have to add the numbers actually from that list, isn't it? So first what you have to do means first you have to select a number which is less than or equal to this 97. So 128, obviously it will be greater than, so you can see like 64, right? So 64, actually I'm using that number, that's why I have given here like a binary value like 1, then 32, so 32, isn't it? So I have to use that number. So 4 plus 32, it will be 96, isn't it? So then if I use 16, actually it will exceed that 97, so no need to use that one. So to construct this number, so for actually we got this one is 96, right? So to construct this number, one more value we need, isn't it? So you can use this one. So the last one, that is plus 1, means that will be 97, right? So the number which I'm going to use is 1, means you can keep here 1. Remaining all you have to use 0. Okay. Okay, now let us complete the next row, that is 108. I have to construct the value like 108, right? So the first one is 128, so you can ignore that one because that is a bigger number than this 108, so you can give a 0 here. Then 64 plus 32, obviously it will be 96, okay, you can keep 2 ones here. 96 plus 4, it is 108, so you can keep 1. So remaining all you can give 0. Okay, this is the way how to convert. The next one is 105. So this 128 is bigger than this 105, so you can keep 0 here. So 1 means this 64 plus 32, that is 96, isn't it? Then plus 8, it will be 104, right? Plus 8, it is 104. Plus 1, it will be 105, right? So remaining 2 boxes you can give 0. Then for 103, this one keep 0, then this one and this one, so you will be getting 96, right? So 96, then 4, that is 100, then 102, then this one 103, right? So you will get 103. So next one is 110, right? So for 110, the first one obviously it will be 0, then 1 1, so this will be 96, right? Then again 0, then 1 1 1 and 0. Okay, this is your final answer for part A question. Okay, now let us move on to the next question, that is part B. An encryption system works by shifting the binary value for a letter one place to the left. A then becomes, so some value is given actually in the binary table, right? So here a term is the encryption. So what is meant by encryption means it's nothing but the data or information which will be scrambled, means which will be in an unreadable form. In the later session you will be learning in detail about this encryption. Okay, here it says an encryption systems work by shifting the binary value for a letter one place to the left, means for the letter A. Actually here you can come to the previous table. Here one place to the left means if you move actually this entire row one place to the left, means this 0, actually the first 0, it will be going out of this binary table, right? So this 0 actually it will be moved to means outside the binary table. So this 1 will be come to the first position here, so this will become like this, right? 1 1, then this will be 0, then this will be 0, then this will be 0, and again this will be 0, isn't it? Then here this position 1 will be there, and here this will be blank obviously, then it will be 0. That's what it is given here, like double 1, 4 zeros are there, then 1 is there, then the last one the empty box actually how to give 0. Okay, so now this binary value is then converted to hexadecimal. The hexadecimal value for A will be C2. So now the result we got, no, like 1 1 00 00 10, you have to convert that value to the hexadecimal value. So you know how to convert this one to the hexadecimal value. First actually how to group this one, means each and every group like 4 digits, 4 binary values will be there, right? So like when you group this one from the right hand side 1 2 3 4, so you can keep a vertical line here like this. Now 1 2 4 8, then here also 1 2 4 8, right? Now what I have to do, I have to strike out the zeros, isn't it? When you strike out this 0, this 1 and this 1, remaining what is there? 2, so that is the 2. Now here also like strike out the 0, now this will be like a 12, isn't it? 12, the deanery value when you take this one to the hexadecimal notation, so it will be C. That's why C2 is there, right? Okay, now see that last question, that is for the two letters L and G, shift the binary values one place to the left and convert these values into hexadecimal. So where actually L is there, this one, right? This one L and G, you have to move one place to the left. When I move actually this one one place to the left, this 0 will be going out, so it will start from 1, isn't it? So like 1 1 0, then double 1 0 0, so the last actually the box it will be empty, so you have to simply keep 0 here. The next one is G. G also what actually how to do, you have to move actually you have to shift one place to the left, so this 0 will be going out, so you have to start from like 1 then 1, isn't it? So 0 0, then it's triple 1, then the last one is 0, right? So now what is the next step? You have to convert this one, this convert actually this result to a hexadecimal number. So first you have to group this one 1 2 3 4, right? Keep a vertical line here, Now 1 2 4 8, right? So here actually wherever 0 is there, you can cut that part. This one, or we can cut this one, this one, right? So this will be 8. The 8 actually you can give. Then here you can cut this 0. Then this will be like 1 2 4 8, right? So when you strike out this one, you will be getting the result. This one will be 13, isn't it? In hexadecimal notation, 13 means that is D. So the answer is D8, right? Then the last one here you have to strike out the 0. So this will be 14, right? 14 means that is E. Okay. Then here you will be getting 12, so you have to strike out these two. Then 12 means that is C. So the final answer is CE, isn't it? That's all.